All right, so now let's try some of the homework together. I want to go over the instructions for each section first. The first section is what we've been doing. We're trying to write out the sums and evaluate them if possible. So we might get something that looks like an equation with x's, and then we just leave it. Notice how they all end. They don't ever go to n. So that's one thing you may have to do, or that you will have to do right here. And then the second instruction is actually the reverse. Could you take these and think of what the sum would be written out as? So could you write this from these pieces here? And that's always fun to think about what the rule is. When I have, was it 7th or 8th graders, they have a function box where, all right, 4 went in, something happened, and 2 came out. So you could think about what the function did. But then if I put 3 in and then 7 comes out, well, now that changes your rule. So you have a couple of things right here, and you're going to try to figure out the rule. I think it's important to do B because this is a powerful notation when you have this -1 to the n. This is the flip-flop of the sign. To put in our terms, we're going to start our index at 1. So -1 to the first power is -1, and 1 squared is 1. So that's our answer right there. Next, we're going to go to 2. So -1 to the second is +1. So essentially positive times 2 squared, which is 4. So +4. Then we get to 3. -1 to the third is a negative. And then 3 squared is 9. So this is -9. And keep doing that with 4 and 5. We can evaluate this one by adding all those together, which is -15. Notice in these, you have an x. That's a variable. That's not going to be changed by the 2. Only the I is going to be changed. Same thing here. Only the I is going to be changed. So these two are not going to be able to be evaluated, but you will write them out. And if you can condense them by factoring out something, you can do that too. So now these, we're going to figure out what the sum's going to be. Start by writing your summation symbol. Have your index equal to, and then you have to kind of pause. The first thing you should kind of note is this flipping back and forth with its sign? It is. So you're going to have -1 to the, and I'm just going to write I right now. It could be I plus 1 if things start negative and then go positive. But if we look at the one that we had up here, the very first term we had, the 1 term turned out to be negative. Our very first term is not negative, it's positive. So there's a couple things that could happen. I could be starting my index at 2, although I'm looking at these and seeing that there's squares. So I probably want to start my index as 1 if I want a 1 in the denominator. So that means, how do I get this to be positive right away instead of negative right away? Well, I could do this value -1 or this value +1. Both result in the same thing. It's going to give me a positive first, starting at index of 1. So let's go ahead and do that. I'm just going to write I plus 1 because I like positives. And now that is just my sign, my positive sign. I think I kind of justified why I want to start at 1 because this is over 1. And then this would be like 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So I want to go to 6. And now this is 1 over, it looks like my index value squared. So I was using the letter I for my index value. Here they use the letter N, whatever you want. And that should do it. You can test it out to make sure it's going to work. So plug in a 1, you get out 2. So -1 squared is +1. And that's going to make it 1 over 1, but positive. Then try 2. -1 to the third power is -1. So negative times 1 over 2 squared, which is 4. So -1/4. And then you can kind of see everything else is going to work out. So This is your answer, the sigma notation. So now let's do one with a factorial. A factorial is the exclamation point here. And whatever number is in front of the factorial, you're going to multiply it by everything down to 1. So 4 times 3 times 2 times 1, which would be 24. 3 factorial is 3 times 2 times 1, which is 6. So we're going to do 7, which utilizes that factorial. So let's use a j this time, starting, I guess we don't know where we're going to start at. So forget I wrote anything there. It looks like we have a fraction bar, so let's start with that. Looks like I go up to 12, 1, 2, 3, all the way to 12, but there has to be something here because that's where I'm starting. So I'm guessing that's 0. And what I need to tell you is that 0 factorial is 1. So 0 factorial is x to the 7th over 1. So we start at an index value of 0 and go to 12, with the index being factorialed. Next, we have x to the 7th in the numerator. And then things start to change. It looks like I'm adding 2 each time. So add on 2, but it needs to change based on the index. So let's just see if I take 2 times that. Because at first it's 0, so 2 times 0 is 0. X to the 7th is what I start with. And then 1, 2 times 1 is 2. 7 plus 2 is 9. That's what I get out next. Seems to work so far. 7 plus 2 times 2 would be 11. And that works. And then maybe we just jump to the way end and do the 12. 7 plus 2 times 12, which is 24. 7 plus 24 is 31. So this would be your summation for this with the factorials. Again, notice we didn't start at 0. There might be some of these that actually start at 2 or 3. You don't have to start at 1. But just to be creative with that and to think outside the box. Whenever it's straightforward positives, you don't have to worry about it. But if you ever have that alternating back and forth, don't forget that -1 to the whatever index power you want, or +1 if you want to make it into positives first. These at the bottom would be very similar to the ones at the bottom of our practice. Express this in closed form. And here's one with the limit. Express this in closed form as n goes to infinity. So there's nothing more we need to talk about with summations. The next thing we'll talk about is area. And this is not due, but if you are off and we have that snow day and you want to get it done or work through it so you have less things to do when we get back, that's fine. But we do have makeup days for a reason, but we were at a point where we are ready to go on to the next part from class today. Otherwise, I'll talk to you later. Bye-bye. I forgot the smiley faces on this page. So there they are.